Assalamualaikum and hi, my name is Nur Alia Nabila binti Muhammad Faisal. My matrix number is 310022. Here, I will explain the answer for question A that form a system of three simultaneous equations in three endogenous variables y, c and t. For first equation will be y equal to c plus I0 plus G0. First, we need to transfer c to the left side with y. So the final equation will be y minus c equal to I0 plus G0. Second equation will be c equal to C0 plus BYD. YD is equal to y minus t. We need to substitute YD equation into C and it will be C equal to C0 plus B bracket y minus t. And then we need to multiply B into y minus t and it will be C equal to C0 plus by minus bt. In the final equation, we need to transfer positive by and negative bt to the left side with c. The final will be minus by plus bt plus c equal to c0. And final equation will be t equal to t0 plus ty. And then we need to transfer positive ty with t at left side. And the final equation will be minus ty plus t equal to t0. For question B, we need to transform the above three simultaneous equations into the matrix form. This question, we need to use the matrix inverse method that A times X equal to D. Definition for A is 3 times 3 and X is 3 times 1. For first column for A, have a 1, negative B and negative T. For second column is negative 1, 1 and 0. For last column for A is 0, B and 1. For X column, we have Y, C and T. And the answer will be I0 plus G0, C0 and T0.
Hi, my name is Nur Farhana binti Azman. My matric number is 305568. Hello everyone. Today we are going to solve question C1 using the matrix inversion method, which is a powerful technique to solve simultaneous equations in our macroeconomic model. We want to find the equilibrium values of three variables: income, consumption, and tax. First, let's identify the variables we are solving for. These are the endogenous variables: income, which we call Y, consumption, which we call C, and tax, which we call T. These are the unknowns in our system of equations. Next, we write the system in matrix form. The system has a coefficient matrix, which is a 3 rows and 3 columns. The first row has the number 1, negative 1, and 0. The second row has negative B, 1, and B. The third row has a negative t, 0, and 1. We also have a constant vector with 3 entries. The first entry is autonomous investment plus government spending. The second entry is autonomous consumption. And the third entry is autonomous tax. To solve the system, we use the matrix inversion method. This means we multiply the inverse of the coefficient matrix by the constant vector. But before we can do that, we must check if the inverse exists by calculating the determinant. The determinant is calculated by expanding along the first row. Remember the sign rule: plus, minus, plus. The first element is 1. Its minor is obtained by removing the first row and first column. The determinant of the minor is 1, so the first term is 1. The second element is negative 1. Its minor is obtained by removing the first row and second column. So the determinant of the minor is negative b plus b times t. Because the element is in the middle, we apply the minus sign from the rule, giving us negative of b minus bt. The third element is 0. Multiplying by 0 gives 0, so we ignore it. Combining all terms, the determinant is 1 minus b times 1 minus t. which is not 0 because B and T are both between 0 and 1. Therefore, the inverse is as is. Using the adjoint method, we write the inverse matrix. A is 1 over the determinant multiplied by a new 3 by 3 matrix. The first row has 1, 1, negative B. The second row has B times 1 minus T, 1, and negative B. And the third row has T, 1 minus B. Next, we multiply the inverse matrix with the constant vector to get the solution vector. This solution vector contains income, consumption, and tax. The equilibrium level of income is equal to the sum of autonomous consumption minus B times autonomous tax plus autonomous investment plus government spending, all divided by 1 minus B times 1 minus T. The equilibrium tax is autonomous tax plus T times equilibrium income. The equilibrium consumption is autonomous consumption plus B times the difference between equilibrium income and equilibrium tax. To conclude, using the matrix inversion method, we can solve a system of simultaneous equations efficiently. Because the determinant of the coefficient matrix is not 0, the system has a unique equilibrium solution. This completes the solution for question C1.
Hello everyone, my name is Wan Najwa Batrisha binti Wan Muhammad Tarmizi, metric number 305344. So, we are going to solve a 3-sector national income model. My question is C2, which is I need to find the equilibrium values for income, consumption, and tax using Cramer's rule. Okay, first we look at our given equation. To use matrix algebra, we must organize them so that all our unknowns y, c, and t are on the left side and our constant are on the right. From our first equation, we get y minus c equal to I0 plus G0. By substitute disposable income y minus t into the consumption function and moving terms, we get negative by plus c plus bt equal to c0. Finally, the tax equation becomes negative ty plus t equal to t0. Now we have a clean system for 3 equations. Next, we transform this system into the matrix form AX equal to D. The matrix A contains our coefficient. Notice the first, negative B and negative T values. The vector X holds our variable Y, C, and T. And the vector D contains our autonomous component like investment and government spending. Before applying Cramer's rule, we must find the determinant of matrix A, which we call delta. By expanding along the first row, we calculate the determinant to be 1 minus B in bracket 1 minus T. Since B and T are between 0 and 1, this determinant is positive, meaning a unique solution exists. Now, let's solve for equilibrium income Y star. According to Cramer's rule, we create a new matrix A1 by replacing the first column of A with our constant vector D. We calculate the determinant of this new matrix and divide it by our original determinant delta. This gives us the final formula for Y star. This represents the total level of income where the economy is in balance. We repeat this exact process for consumption C and tax T. To find C, we replace the second column with the constant, and to find T, we replace the third column. Each time, we find the new determinant and divide it by our original delta. And that is how you solve a macroeconomic model using Cramer's rule. It allows us to see exactly how change in parameter like the tax rate or the marginal propensity to consume affect the entire economy.